Okay, so we're trying to find the distance and midpoint between these 2 points we've been given. First thing I do when I see 2 points like this, and I'm thinking any kind of physical parameters, is I try to make a graph of them mentally. I don't always write it down. I'm going to this time just so that we all share the same mental picture here, and it actually looks the same. But I find that it helps me. It helps me catch mistakes. So I'm going to draw out my coordinate system here. Draw out my horizontal line here. And if I'm looking at these numbers I've got kind of 1/3, I've got kind of 2.5 here with the 5/2. I've got kind of, what's that going to be? That'd be like 3 and a little bit, 3 2/3. And I've got -1/2 here. That looks like it would live nicely in a graph that was on a -5 to 5 scale. And so let's do that. Let's just mark out 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. We're not talking accurate, we're talking sketch. But the idea is this can help us catch errors. It can help us figure out when we're doing something silly, because we all do silly stuff with math. Every single person that does math makes mistakes. The thing that makes some of us start to be more reliable than others is we start to figure out how to catch those mistakes, how to make sure that we don't let those mistakes enter into our larger work. Okay, well, let's think about these 2 points. It's kind of point 1 and point 2. So if I kind of think about this one on the left as my point 1, we're going to say that's the x1, y1, right? Because this is an ordered pair. And we kind of have point 2, and that's kind of my x2, y2, because we have an ordered pair there. Really ought to give myself a little more space and say those are equal. Okay. So I kind of got my point 1, my point 2, and I want to graph them. So if I'm looking at point 1, -11/3. Well, I want to think about the remainder. The remainder, it's going to be 2/3 is the remainder. And the integer part is going to be what? 9/3. And 9/3 is going to give me 3. Okay, so I'm going to be at 3 2/3 negative. So I got 1, 2, 3, and then 2/3. And so that's my -11/3. Okay, now in the y direction, I'm at -1/2. So I'm down there, right? So my point is, well, that's actually, the point looks a little low to me now that I'm looking at closer to there. Okay. And so that's a good kind of hello world, point 1 is here kind of thing. All right, now let's do point 2. Point 2 is going to be 1/3 out in the x direction. It's going to be pretty close to that x-axis, or that y-axis, sorry. And yeah, let's label those. We really ought to label those. X-axis, y-axis, things we should do. And so there's my 1/2, and now that's going to go up to 5/2. Well, 4/2 would be 2, and that leaves me with a remainder of 1/2, and so that's going to be 2.5. So that's going to be up here at 5/2. So that's 1/2. That's 5/2. And so my point is over here somewhere. And we kind of have hello world, that's point 2. And again, I usually wouldn't draw this, but I want the mental picture. So when I'm thinking about distance, I'm really just thinking, do they connect the dots here? Those two connect. I'm thinking about how far is one point from the other. And when I'm thinking about midpoint, I'm guessing the midpoint looks like it's going to be about there. Don't know exactly what the coordinates are going to be, but it should be in that general area, right? Plus or minus a bad sketch, plus or minus my ability to put a grid together. Okay. Well, now let's do the math and see if our graph helps us make sure that we're doing the math right. So when I put this together, I'm going to remember my distance formula. And my distance formula comes from the Pythagorean theorem, right? Because this is really, if I want to keep, sticking with the graph for a minute, this is really kind of like my triangle goes over here and comes down here, and I got a right triangle there. And this is really kind of like my a squared and my b squared, and that's my c squared, but that's really the distance that I'm after, right? It's just that this is my change in x, and this is my change in y, would be that length, and would be that length. And so in a sense, I don't really have to memorize a new formula. This is just Pythagorean theorem, because the distance that I've been asked to find, which is, the length of that that piece of the triangle, the hypotenuse of the triangle, is just going to be d squared equals delta x squared plus delta y squared. So there's not a new formula to memorize here, which I love. I don't like memorizing things. Memorizing things is not fun. I like to memorize things by usage or by reasoning, at least whenever possible. Sometimes you have to. Sometimes you absolutely have to, but I think it's a lot nicer when you can think through it. All right, well, in this case, I'm going to take the square root of both sides because I'm asked about d. I'm not asked about d squared. And I also know I don't really care about direction. So I'm not going to write the plus or minus because I really don't care about a negative distance. All I care about is the magnitude of the distance. And so this is going to be d equals the square root. And instead of delta x, I'm going to write in x2 minus x1 squared plus y2 minus y1 squared. Okay. And that's the formula that most textbooks would give you. But you don't really have to memorize it character for character. You can get there more easily than that. Now, how do I actually do this? Well, I take my x2 value, which is 1/3, right? So I got my d equals, and I got my big square root thingy, and it's probably going to be longer than that, so I'm probably going to regret putting that little down tick there. All right, so what do I have? I got my x2 is 1/3, and I've got my x1 is negative 11/3, so it's minus parentheses minus 11 over 3. That whole thing squared, plus, I've got my y2, that was 5/2. And my y1, what's another negative number? So I have minus, and then parentheses, minus 1/2. That's all in parentheses, that's squared. And what did I say? I thought that I was going to regret that downtick because it was longer than it needed to be. Okay. Fortunately, though nobody really enjoys adding fractions, at least these fractions have the same denominator, right? Numerator tells me how many pieces I got. Denominator tells me what size the pieces are. Since they're the same size pieces, I can combine them. So I do combine them. Minus a negative is going to be positive, right? And so if I work this through, I'm going to kind of do this in between. I've got 1/3 plus 11/3 equals 12/3. But 12 is 3 times 4, so I could say this is 3 times 4 divided by 3. The 3's cancel, and that's going to leave me with a 4. And so I know that down here where I say equals and I put my big square root, that this is just going to be 4 squared. Okay, now let's do that for the other one. What's that going to be? It's going to be 5/2 minus a negative will be plus 1/2. That's going to be 6/2, right? 5 plus 1 over 2. But 6, that's going to be something different, right? Because we can say that 6 is 2 times 3 divided by 2. 2 divided by 2 is 1. 1 times 3 is 3. And so the 2's go away. And so that's going to leave me with a plus. Please write. Come on. There we go. Plus 3 squared. All right. There was a little bit of a pause in there. Had a couple of things happen in my office hours. And I'm putting these videos together during my office hours, so had to step away for a second. Now that I'm back, let's finish this up. So we've got the square root of, and we've got the 4 squared plus 3 squared. Well, that's going to be pretty straightforward, right? Because 4 squared is going to be 16. So if I kind of keep writing this out, I've got the square root of, and then I have my 16 plus 9. Well, that's going to be the same thing as the square root of 25, which will be the square root of 5 squared, which is just 5. And so I know my distance. My distance now equals 5, which seems pretty reasonable if I go back and I look at that graph and I think about the lengths of those sides, because what we said is that the distance in x, or the difference in x, was 4. We said the difference in y was 3, and so the hypotenuse is longer than either side. So yeah, 5 seems like a reasonable answer. It also happens to be one of those special triangles that people memorize, is a 3, 4, 5 right triangle. So as soon as you see the 3 and the 4, if you're kind of an experienced math nerd that memorizes things, you're going to know that that's a 3, 4, 5 right triangle, and so you know the answer 5 is coming. Okay, so we've got the distance. Now we want to find the midpoint. What I always say for midpoint, as far as remembering the formula, is think average, because the midpoint is the center of the line segment. And rather than thinking about memorizing something new, I want to think an average. It's a measure of central tendency. And if it really does work, just to think about averaging the x-coordinates and averaging the y-coordinates. Well, what do I do when I calculate an average? I add up all the things, and then I divide by the number of things, right? Well, if I've got 2 x-coordinates, it'll just be the 2 x-coordinates added together, then divided by 2. And then the 2 y-coordinates added together and then divided by 2. And if you take a look at the textbook says that my midpoint formula, so midpoint, I'm going to have to change this real quick. All right, my midpoint formula is x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. Okay, well, what were my x1s and my y1s? Well, my x1, it's what I wrote in black up here in the upper left. So it's the negative 11 thirds would be my x1, and my x2 would be 1/3. And so that'll be negative 11 thirds plus, we got ESPN kicking in here, plus 1/3, and that's all divided by 2. Kind of looks ugly as a complex fraction, but we'll face that in a minute. All right, now let's take a look at our y's. We've got our y1, which is going to be negative 1/2, and our y2, which is 5/2. So I have negative 1/2, and then I have plus 5/2, all divided by 2. All right, well, let's evaluate that. Let's put another page here so we can have a little space to think. All right, well, again, in our numerator, we have addition of fractions, but they've got the same denominator, so we can combine the numerators, right? This is like I was saying earlier, the numerator tells me how many pieces I have, the denominator tells me what size those pieces are. And so if I've got the same size denominators, I can combine the numerators. I can group those things together. And so I have negative 11 plus 1, which is negative 10. All right, so I have negative 10. Oops, give me my pen back. There we go. Negative 10 divided by 3, all over 2. That's my x-coordinate. And then by the same reasoning here, this is going to be 4/2, right? But if I think about it, as I just kind of think over here on the side and sketch a little bit here, I've got negative 1 plus 5 over 2 gives me 4/2, but 4/2 is 2 times 2 over 2. 2 over 2 is 1, so those cancel, and I'm just left with 2, right? And so now I have literally, I'll keep the black color there for a second, because now I literally have 2 for that numerator divided by 2 because of the average, because of the denominator there. All right, couple of different ways to handle this as far as thinking through what I want to do with this 10 thirds divided by 2. My mind says it's easier to think of that 2 as 2 over 1, and I can convert division to multiplication by multiplying by the reciprocal of the thing I'm dividing by. It's a big mouthful, but what it leaves me with, the end result, is that I have negative 10 thirds times 1/2, comma, 1, because this is 2 divided by 2, that's 1. And so that 1/2, I take the reciprocal of it, which means I exchange the numerator and denominator, and I turn it into multiplication. You can remember some of our work with complex fractions earlier. That's a byproduct of that. All right, well, I'm thinking of 10. 10 is 2 times 5, right? So that's actually going to cancel with the 2. And so if I'm thinking over here, I've kind of got 10 times 1 divided by 3 times 2. Well, that's 2 times 5 times 1 divided by 3 times 2. But 2 divided by 2 is 1. So the 2's cancel. It leaves me with 5 thirds. And so what I really have over here is negative 5 thirds, comma, 1. All right, now, the moment of truth. I want to scroll back up, and I want to take a look at my sketch. And I want to see if negative 5 thirds, comma, 1 is even in the ballpark of where I put that dot at the very beginning of this. I don't even want to know how many minutes ago. So negative 5 thirds, comma, 1, be back about 1 2/3 on the x-axis and up 1. And if I scroll back up here, oh wow, it's almost like I knew what I was doing. Back 1 2/3 and up 1 looks almost exactly like where that midpoint is. And so I'm proud, I'm happy that midpoint makes sense to me. Not only do I have an answer, but I feel confident in that answer because that answer makes sense to me. It's awfully nice when you're leaving a test. It's awfully nice to feel confident in your answer. And that's part of why I really recommend sketching in something like that when you're working these problems, because it does help you feel confident about your answers, and it helps you catch those silly little mistakes that everyone makes. All right, I hope this helps with your studying.